अब देखो हम लोग का ये आगे बढ़ते हैं थ्योरम 2.10.1 a function which is continuous on closed interval ab assumes every value between its bounds. देखो इसका प्रूफ since f is continuous on closed interval ab क्या लोग करते हैं since f is continuous on closed interval ab so it is bounded and attains its bounds on closed interval ab. तो लेट अल्फा बीटा बी इन क्लोज इंटरवल ए बी मान लेते हैं कि अल्फा बीटा दो मेंबर हैं क्लोज इंटरवल ए बी में, तो दो एलिमेंट हैं सच दैट एफ अल्फा इज इक्वल टू स्मॉल एम इज द ग्रेटेस्ट लोअर बाउंड ऑफ एफ इन क्लोज इंटरवल ए बी. लोअर बाउंड है सारे उनमें सबसे बड़ा हो गया. एंड एफ बीटा इज इक्वल टू कैपिटल एम, इट इज द लीस्ट अपर बाउंड ऑफ एफ इन क्लोज इंटरवल ए बी. सिंस एफ इज कंटीन्यूअस इन क्लोज इंटरवल ए बी, therefore it is continuous in closed interval alpha beta. Therefore f assumes every values between f alpha and f beta. Thus we can say that the range of a continuous function on a closed interval is a closed interval. Next है preservation of intervals theorem. Let I be an interval and let f be a mapping from I to R be continuous on I. ये function continuous है. Then the set fi is an interval. ये हमको show करना है. Before understanding this theorem, readers should understand the following points. इन points को समझ लो पहले. First है characterization of intervals. Let I is an interval if xy belongs to I such that x is less than y. दो नंबर है या दो एलिमेंट xy और x less than y and both of them are in I. Then any point between x and y will also belong to I. यानी x और y के बीच का कोई पॉइंट है तो वो भी I में होगा. That is, if x is less than k less than y, then this small k belongs to I. Further, we can say that closed interval xi is contained in I. चूंकि xy I में है, तो closed interval is contained. We will now write the statement of characterization theorem, which says that a subset of R possessing this property must be an interval. देखो characterization theorem क्या है? If I is a subset of R that contains at least 2 points AB in I such that A is less than B, then closed interval AB is contained in I. Then this I is an interval. Now the preservation of intervals theorem says let I be an interval and let F be a mapping from I to R be continuous on I, then Fi is an interval. ये तुम्हारा preservation theorem कहता है. Preservation intervals theorem. अब आते हैं इसका हम लोग प्रूफ देख लेते हैं. Proof. Let alpha beta belongs to Fi with alpha less than beta. Then there exist 2 points AB in I such that alpha is equal to Fa and beta is equal to F. कोई दिक्कत इसमें नहीं है. By intermediate mean value theorem, we can say that for t in open interval alpha beta, there exists small k in I such that t is equal to Fk, which belongs to Fi. ये intermediate mean value theorem जो हम लोग पीछे पढ़े थे, से निकला है. So we can say that t belongs to closed interval alpha beta implies t belongs to Fi. Therefore, closed interval alpha beta is contained in Fi. So by characterization theorem, this Fi is an interval. Next, एक concept है uniform continuity का. देखो, a function f is said to be uniformly continuous on the interval I if given any epsilon greater than 0, there is delta greater than 0 depending on epsilon such that mod fx1 minus fx2 is less than epsilon whenever mod x1 minus x2 less than delta for all x1 x2 in I. देखो यूनिफॉर्म कंटिन्यूटी इंटरवल I पर है, जबकि कंटिन्यूटी होता है एक पॉइंट पर. कोई रिमार्क? कंटिन्यूटी इज ए लोकल प्रॉपर्टी but uniform continuity is a global property. It does not make sense to say that a function is uniformly continuous at a point. No, we need to say that a function is uniformly continuous in an interval, not at a point. Next, continuity of a function is defined at a point, but the uniform continuity of a function is defined in an interval. When we say that function is continuous in an interval I, it means that f is continuous at all points of the interval. In case of continuity of a function at a point C, the choice of delta greater than 0 depends upon epsilon greater than 0 and the point C. But in case of uniform continuity of a function, delta greater than 0 depends only on epsilon greater than 0 and not on pair of points of the given interval. यही अंतर है. Continuity में point C पे depend करता है, but uniform continuity में point पे depend नहीं कर रहा, not on pair of points पे depend नहीं कर रहा. If a function f is uniformly continuous on I, then it is continuous on I, but converse may not be true. यानी कि uniform continuity implies continuity, but continuity may not imply uniform continuity. We will show it by an example. अब देखिए non-uniform continuity criterion. A function f is not uniformly continuous on I if there exists an epsilon greater than 0 and two sequences xn and yn in I such that limit xn minus yn is equal to 0, but modulus of xn minus fyn is greater than or equal to epsilon for all n in n. अगर ये less than रहता तो बात हो जाएगी uniform continuity. But चूंकि this is greater than or equal to 0, so it is not uniformly continuous. Next, theorem देखो. A uniformly continuous function on an interval I is also continuous on I, but converse may not be true. Proof देखा जाए. Let f be uniformly continuous function on an interval I. तो इससे हम दिखा देंगे कि continuous है. Let epsilon greater than 0 be given. Since f is uniformly continuous function on I, we can find a delta greater than 0 such that mod fxn minus xn less than epsilon for all xn xm in I and mod xn minus xm less than delta. By taking xm is equal to small l ले लेते हैं और इसमें सब्स्टिट्यूट कर देंगे. Then mod fxn minus fl less than epsilon when mod xn minus l less than delta. So by sequential criterion for continuity, f is continuous at L, this point L, which is a point of I. Since this L is an arbitrary point, so f is continuous at every point of I. यानी कि यूनिफॉर्म कंटिन्यूटी से कंटिन्यूटी तुम्हें मिल गया. But converse is not true, may not be true. Consider a function f defined by fx is equal to 1 upon x, where x belongs to this open interval 0 infinity. We know that x is continuous on 0 infinity. कोई function x is 0 infinity continuous होगा and x is not equal to 0. So 1 upon x is continuous on 0 infinity, open interval 0 infinity. Let xn is equal to 1 by n and yn is equal to 1 by kn. K and n both are in n and small k is constant. Therefore, mod xn minus yn will be 1 upon n minus 1 upon kn. Substitute the values. This is equal to k minus 1 by k into n, and it will tend to 0 if n tends to infinity, as n tends to infinity. Therefore, limit mod xn minus yn is equal to 0, but mod fxn minus fyn is equal to kn minus n. It is equal to k minus n 1 into n modulus of, and it will be greater than epsilon. So this f is not uniformly continuous on open interval 0 infinity. It means the continuity है, it does not imply uniform continuity. ये हम लोग एक एग्जांपल से हम लोगों ने दिखा दिया. इसके बाद एक थ्योरम है, इसको भी देख लेते हैं हम लोग. Uniform continuity theorem. If f be a mapping from AB to R and it is continuous on closed interval AB, then it is uniformly continuous on closed interval AB. अगर ये closed interval है तो continuity imply करेगा uniform continuity. और a continuous function on a closed interval is uniformly continuous on the thing. देखो इसका proof. Before proving this theorem, reader should read the following points. सब sequence के बारे में जानने पहले हम लोग. Let xn be a sequence of real numbers and let n1 less than n2 less than n1 less than nk less than be a strictly increasing sequence of natural numbers. ये सारे natural numbers हैं और n2 n1 से बड़ा है, n3 n2 से बड़ा है, and so on. So this is increasing sequence. Then the sequence x and k given by xn1, xn2, xn3 and so on is called the subsequence of x. यहाँ n1, n2, n3 क्या है? Increasing sequence. For example, if xn is equal to 1 by 1, 1 by 2, 1 by 3 and so on be a sequence, then xnk is equal to 1.2, 1.4, 1.6, 1.2 is the subsequence of xn. क्यों? क्योंकि ये जो n1, n2, n3 increasing sequence हो गया और उनके corresponding ये भी एक हमारा sequence हो गया. So it is your subsequence of x. और xnk is equal to 1 by 1, 1 by 3, 1 by 5, 1 by 2, k minus 1 and so on is the subsequence of xn. But 1.2, 1.1, 1 by 4, 1 by 3, 1 by 6, 1 by 4 is not the subsequence of xn. क्योंकि यहाँ n1 into n3 हमारा increasing या increasing sequence नहीं होगा, क्योंकि कभी n1 1 है, कभी n2 2 है, कभी n3 2 से कम है, कभी 10 है, कभी 8 है, कभी 9 है ऐसे. So it is not the subsequence. If a sequence xn of real numbers converges to a real number n, कोई sequence है real numbers का वो x को converge करता है, then any subsequence xnk of xn also converges to x. अगर इस xn का कोई और subsequence लेंगे तो वो भी x पे converge करेगा. इसके बाद एक है इसमें बोल्जानो-वेयर्स थ्योरम और फिर प्रूफ है. देखो बोल्जानो-वेयर्स थ्योरम, a bounded sequence of real numbers has a convergent subsequence. And fourth, if xn is a convergent sequence, then xn belongs to closed interval implies limit xn belongs to closed interval for all x in n. Now the proof. Let if possible f is not uniformly continuous on closed interval. मान लेते हैं कि f is not uniformly continuous, and later on we will move to the fact that it is a contradiction. Then we can find two sequences x and y in closed interval AB such that mod xn minus 1 by n and mod fxn minus f1 is greater than or equal to epsilon for all n in capital N, where epsilon greater than 0 is however small. Okay. Since xn is bounded in closed interval AB, therefore by point 3 Bolzano-Weierstrass theorem, there exists a subsequence xnk of xn that converges to C. Since closed interval AB is closed, therefore C belongs to closed interval AB. Therefore, this sequence xnk converges to C belongs to closed interval AB. Therefore, mod xnk minus C is less than or equal to mod xnk minus ynk plus mod ynk minus C. By sequential criteria of continuity, sequence xnk converges to C, sequence fnk converges to fc, and sequence fynk converges to fc. But it is not possible because of this one. This is greater than or equal to epsilon, so this sequence does not converge to fc. It means sequential criterion of continuity does not hold, which implies f is not continuous on closed interval AB, and hence it is a contradiction. ये क्या हो गया? Contradiction हो गया. So f is uniformly continuous on closed interval AB. Hence, if f is continuous on closed interval AB, then f is also uniformly continuous on closed interval AB. यानी कि continuity, uniform continuity imply करेगी जबकि interval closed हो. अब एक example इस पे देख लो. Example based on uniform continuity. Show that the function f defined by fx equal to 2x square minus 3x plus 5 is uniformly continuous on closed interval minus 2, 2. देखो solution. Let epsilon greater than 0 be given. Let x1, x2 belongs to. Let x1, x2 belongs to closed interval minus 2, 2. It implies that mod fx1 minus fx2 will be equal to modulus of fx1 की वैल्यू यहाँ रखेंगे यहाँ से 2x1 square minus 3x1 plus 5 minus 2x2 square minus 3x2 plus 5 plus 5 minus 5 cancel. So it is 2x1 minus x2 into x1 plus x2 minus 3 into x1 minus x2. यहाँ पर सिर्फ 3 minus 3x1 plus 3x2 है, minus 3 बाहर लिया x1 minus x2. अब इस इसमें से x1 माइनस x2 बाहर ले लिए, मॉडुलस x1 माइनस x2 इंटू मॉड 2 x1 प्लस x2 माइनस 3. So this is less than or equal to mod x1 minus x2 into modulus of 2 mod x1 plus mod x2 plus 3. It is less than or equal to mod x1 minus x2 into 2 mod x1 is less than 2 mod x2 is less than 2 plus 3. तो यहाँ से x1 x2 इसमें है तो modulus of this will be less than 2. So 2 plus 2 4, 4 to 8 plus 3 11. It means it is equal to 11 times modulus x1 minus x2. It is less than epsilon. So when it is less than epsilon, therefore modulus x1 minus x2 less than epsilon by 11. Therefore for any epsilon greater than 0, there is delta. Suppose this delta is epsilon by 11. Thus that mod x1 minus x2 is less than epsilon. For mod x1 minus x2 less than delta. It means f is uniformly continuous on closed interval minus 2 and 2. तो ये एग्जाम्पल सॉल्व हो गया. इसके बाद देयर इज वन मोर एग्जाम्पल, हम लोग उसको भी देख लें जल्दी से. Show that the function f defined by fx is equal to x cube is uniformly continuous on minus 2 2. देखो solution. Let epsilon greater than 0 be given if x1 x2 belongs to closed interval minus 2 2. ये भी उसी जैसा है, खाली फंक्शन बदल दिया है. Interval भी सेम है, only the function is changed. So you can do yourself. So mod x1 minus x2 is equal to mod x1 x2 cube minus x1 cube. It is equal to mod x2 minus x1 within bracket x2 square plus x1 square plus x1 x2. It is less than or equal to mod x2 minus x1 into mod x2 square plus mod x1 square plus mod x1 x2. So it is less than or equal to mod x2 minus x1. Mod x2 square is less than 4. Mod x1 square is less than 4 plus mod x1 x2 is less than 2 into 2. So 2 into means 4 plus 4 plus 4. So it is 12. Therefore it is equal to 12 times mod x2 minus x1. It means mod of x2 minus fx1 is less than epsilon whenever mod x2 minus x1 less than epsilon by 12. means इसको लेना है less than epsilon. Suppose the delta is epsilon by 12. Therefore given epsilon greater than 0, there is delta is equal to epsilon by 12 such that mod x2 minus x1 less than epsilon whenever mod x2 minus x1 less than delta for all x1 x2 minus 2 2. This is closed interval. Hence the function is uniformly continuous on closed interval minus 2 2. तो ये प्रॉब्लम भी आपका सॉल्व हो गया. इसी तरह से there is another problem. Show that the function f defined by fx plus x square is uniformly continuous on closed interval minus 1 1. फिर closed interval यहाँ बदल दिया, फंक्शन बदल दिया, रेस्ट चीजें सेम होंगी. तो it is all about for today क्लास. अगर तुम लोगों को कोई प्रॉब्लम है, कोई डिफिकल्टी है तो मुझे पूछो और इसको तुम लोग नोट कर लो.